Well, good morning, everybody. This is R from L47 coming to you from Dallas, Texas. Today is June the 6th, 2011, and I'm making this video at 8:28 a.m. Central Time. Here's a quick look at the water vapor satellite, and it shows that we're kind of in a blocky pattern again. Things are not moving real fast across the lower 48, or even, well, the lower part of the lower 48, should I say, states. We've got a large low sitting out here off of the west coast, and then we've got the high pressure over the central part of the United States, and then we've got another low sitting up here off of Nova Scotia and Canada, and of course it's usually kind of like the polar vortex, although generally we don't look too much at the polar vortex during the summer. And I realize it's not summer yet, but this is looking more and more like a summer pattern as we go. Lots of moisture down here in my area. In fact, yesterday we had some isolated thunderstorms that had some pretty good downburst winds in them, and it's all because of moisture being flung back towards the west. And this little, you can see very little circulation here that's counterclockwise. Will be a low pressure that's throwing moisture back into Texas here. Anyway, overall, the storm pattern remains across the storm track remains across the northern part of the United States, and that's probably where the main chances of severe weather are going to be for the next several days. I would say keep an eye down here to the Caribbean. We are officially in hurricane season, and it wouldn't surprise me to see something come up in the next few days down here out of the National Hurricane Center about something to watch down in this area. This is the time of year that they would start closer to home, as later on in the season is when they start looking out off of Africa. Anyway, that's a look at, I said a quick look, that wasn't very quick, I probably rambled on, yes I did for 2 minutes, but anyway, that's kind of what it looks like here over the lower 48 states when it comes to the water vapor satellite and how things are kind of sitting and not moving too fast. But let's look at where severe weather is going to be today. So the day one convective outlook shows that there is the slight risk of severe storms from Montana all the way into Wisconsin. So mainly again along the northern tier, because that's where the storm track is. A lot of areas of just the pop-up general afternoon scattered thunderstorms. This mainly due to all the tropical moisture down here. We do still have moisture coming in along with that low off of the coast of eastern Canada. But again, main threats of severe weather here are going to be again large hail and damaging wind. So all you people in the northern tier of the United States, just keep an eye out the storms. It's your storm time of the year now. Here's a look at LASCO imagery. This is a C3 look of the really pretty much the chromosphere coming off of the sun. As you can see, we had a very good coronal mass ejection, and when we first saw this one, you see here at the beginning right there, a lot of the computers picked up on that as a full-scale coronal mass ejection, Earth directed. And I've read later this morning that it was a backside ejection. So this large one that we see there was not headed Earth directed. It was headed towards the other side of the sun. So that's good. That will keep that coronal mass ejection from hitting the Earth. We do see another ejection here that probably could clip us, but it looks like it was more to the north side on the came out of the northern hemisphere of the sun, and probably will miss the Earth altogether. You do see a lot of noise. See all these little specks that showing up, and I'll show you what's bringing that up. And I don't have an answer as to why we're having it's a proton storm, not a big one, but another proton event, and I'll show you that. But that, a lot of times, if you're ever looking at satellite and you start seeing this, it looks like, you know, static on, you know, old-time TV or whatever. It's just all these scattered little dots showing up. It's just interference. Here's the chart from the GOES 13 satellite. This is showing a proton flux, in other words, a solar radiation that is hitting the satellite. And we see a decent spike happening in the greater than 10 mega electron volt area, and even agitation in some of the stronger areas. But we had this one back here, which was kind of sometimes as a precursor to a geomagnetic storm, which I'll show you on another chart here in just a second. But again, I'm not exactly sure what has triggered this solar radiation spike. Probably enough almost for a low-level S1 storm, but not that much. But this is what you're seeing, as I was talking about the noise or the static you were seeing in that picture earlier. It's caused by these particles. These are actual X-ray or solar radiation particles that are blasted out of the sun or from somewhere, and causing the interference. And again, it's elevated in all three areas that we measure, so just an interesting phenomenon to keep an eye on. This is a chart of the planetary K-index. The K-index is what we use to measure the intensity of a geomagnetic storm in progress. As you can see, back on the evening of June 4th into the morning of June 5th, we had a pretty decent geomagnetic storm. Now, I told you about we saw the precursor with a jump in the solar radiation event, and a lot of times that's the precursor to a geomagnetic storm, which is sometimes brought on by, again, a coronal mass ejection that finally makes it to Earth, or a disturbance in the solar wind parameters. But anyway, decent storming happened again from again the latter part of the day on June 4th into most of the day on June 5th, and I imagine auroras were seen actually probably pretty far south. I mean, as far south as maybe some like northern Michigan, in areas that normally you don't see them unless we have a pretty decent storm. Again, this is not like a severe storm, but this is a strong geomagnetic storm which occurred. Right now, as you can see, we've dropped off back into the quiet zone. A quick look at the solar wind parameters. As I tell you, I always look at the BZ component, which is the red line on this graph at the top. When it stays to the under this zero line, which would be a negative number, which also indicates a southward direction or a southward component to the solar wind stream. Anytime it stays below, that's when we see the tendency to have geomagnetic storms, or that means our shields are weak. Is an easier way to say it. If you're thinking Star Trek terms, our shields are down. The lower this is, then the more apt we are, or the more susceptible to geomagnetic perturbance than normally we would see. So as you can see, we've had some. Right now it's kind of held right at, I'd say, equal, which means we're fine. You can see again back here, and this is 24 hours ago, we had a pretty decent couple of hours of below zero BZ component there. Solar wind started off at about 480 kilometers per second in this 24-hour period, went up to 540 kilometers per second, and has since then now dropped off. We have a data drop there between 4 and 6 UTC time there. Again, solar winds dropping down. This is generally due to probably a coronal hole on the sun, and a lot of times the wind stream blows. So again, the geomagnetic storming occurred back when this was down south, and the winds were blowing strong there. So right now it looks like geomagnetic storming, or the solar wind parameters at least, don't show any signs of strong geomagnetic activity for now. So aurora watchers, you had your chance a day before yesterday, but believe me, there'll be more chances. Now let's finally take a look at the HAARP magnetometer. So this is the induction magnetometer from the HAARP facility in Gacona, Alaska. We see a lot of noise across for the last several hours. This would be a 36-hour period. So we've got banding, let's call it horizontal banding, what do you say, at several different frequencies. And now this can be caused by the solar proton storm we're seeing. Definitely the ionosphere gets agitated when we have geomagnetic activity. Some of the storming we've had gets picked up on this. We see our normal 1.75 string along here. It's gotten kind of quiet. Again, a lot of times when it seems like I see the small ones at the bottom tend to coincide with some geomagnetic disturbances that are sun related, solar related. So other than that, the HAARP looks relatively quiet. Again, these lines, and I've not studied HAARP that long as far as looking at a chart almost daily, but I've not seen these consistent horizontal lines since I started watching. But that could be, again, background interference from what's going on with the solar radiation storm. So there you have it. Probably a long and tedious, boring look for most people. But anyway, I'd say everything is pretty status quo. There have been some strong earthquakes over the last 24 to 36 hours. We've had some volcano activity, so the Earth is definitely not quiet. The weather's trying to turn into a summer pattern, which here in Texas I don't look forward to. And the sun continues to be semi-active, but it could be a lot more active. Again, we are coming out of a grand minimum. So there you have it. Anyway, y'all take care.